All right, welcome to today's lecture. I think that we will be finishing off the grasp patterns today, so you are fully prepared for the workshop next week, and I hope you have already started, but if you haven't, do so, find a group or do it by yourself, but get started as soon as possible. So it's quite a big workshop, so you need some time to finish it, I think. So first of all, we will be checking the course homepage. Any questions on this? The domain model for the suggested domain model for workshop 1? Nothing? Did it look like something you got? I think most of you at least got some kind of member and some kind of boat and some kind of berth. That's maybe the most important stuff to get. Many of you also had some kind of reservation, sometimes in the form of just an association. I think this could be developed into a class of its own. A reservation could be a tangible thing that the boat club manages. But if you don't have any questions for this, let's move on. Grasp, and we were actually at the this requirement where we left off, and we had dealt cards to the player and to the dealer, and we left the code in the middle, but I fixed it. So right now the game looks something like this. So we can start a game and we can get a printout of the dealer hand, the knight of spades and the hidden of hidden, and the player 2 of spades and the 9 of spades. So I did not do any special kind of printout for the hidden card. So that's just about it for now. And the code is, well, we present the instructions, then we actually present the hands, because this will be looped as soon as we start a new round. We will exit this function and then go into it again. So then you have the hands. So we needed to move that there, and I just put the hand for the dealer and the player and sent them to the view. And the view looks something like this. Gets the dealer hand and gets the player hand, and if we have something, well, then we print it out, and if we have something, we print it out. And this little function here is this one. So just loops, so iterates over the cards in the hand and then prints them. And you could do something more fancy here, of course, but we won't be doing that. Questions? So I actually managed to generate a sequence diagram. In Visual Studio you can generate these based on the code, and that's kind of neat, but you don't really get this one. Get something that is much more detailed and cluttered. So if you opt for this way of doing things, which can be good in a documentation setting, when I'm supposed to leave this to someone else, well, I probably shouldn't leave my design sketch that I did before coding. I should probably either update my design sketch so it actually reflects the code that happened, or I could generate something. But if you generate something, you probably need to clean it up, because you get a really messy diagram if you just leave it as it is. So this is available in Visual Studio. There are probably other tools that can do this also, but something like this is what it's supposed to look. And well, we start out here in main, and the play game is called in the controller. presents the instructions, presents the hands. What happens here? Well, you get the hand from the player, and you display the hand, and you loop over the cards, and you get the value, and you get the color, and you do that once more, and then we're done. And here we have the actual dealing of the card. Start new round in the dealer, get the card from the deck, and show the card, and deal the card, and get the card, and show the card, and deal the card, and so on and so forth. So that it really corresponds to the code, so it should not be a big issue for you, I think. And I also did a class diagram here in Visual Studio, and they're quite good. If you use the architecture option in Visual Studio, you can get quite good class diagrams and make them quite neat. So if you opt for that, you could take a look at it. Basically, it looks something like this. We have a model package. Maybe I should do it something like that. Have a model package that contains our familiar classes: the dealer, the deck, the player, and the card. The dealer has an attribute named m_deck that forms this association to the deck. The deck has a number of cards in his list, and the player has a hand with a number of cards, and the dealer has a hand with a number of cards. And in the view, we could see in the sequence diagram that the view calls get color, get value on the cards, so we have a dependency to the card class. And we know that the controller gets 2 arguments to it, 3 actually. It gets the view, and it gets the dealer and the player. So we need dependencies there also. So basically this is how it looks now. Questions? No? Great. We have a final thing to do actually before this requirement is done, and that is display the scores of the dealer and player hands. So I need to calculate the score of the dealer and player hands. And where should we put this responsibility? The responsibility to calculate the score of a hand. Let's start by breaking it down then. Okay, we will calculate the score of the dealer hand. What do we need to know? We need to know the cards that the dealer has in his hand. Who has this information? The dealer has that because he has access to the cards that he has in his hand. So by information expert, we should put this in the dealer. So let's do that. Let's call it get hand score, get score of hand, maybe it's better. Two, 3, 4, 5, 6, 7, 9, 10, knight, queen, king, ace. What? Yeah. Great. Ace is 11. And 1. So this is a little bit of a tricky situation. So we will be dealing with that situation also. But that is also something that just happens if we get a score over 21. So we want a score that is as close to 21 as possible, but not above it. And if we have an ace and go above 21, we should count this ace as 1. So points, maybe. First of all, we need to check if the card is hidden. If it's not, then we can get the value and add the score. So something like that. So now we just index this points array with the enumeration for the value. The color doesn't really matter. So we will get, if we get the value of 2, we will get 2 points, and 3, and so forth. So forth, and for the ace we get 11. But we need to handle this ace stuff if score bigger than 21. We should actually loop once more. And if the value of the card we get is the ace, that's it to start, then we should deduct 10 points. If score and if we get a valid score by doing this, we end this loop and break out and return the score. So not really magic, but this is what we need to do. So we get as high a score as possible, but not over 21. So other options actually for doing this is to put the score into the card class. The card manages his color, his value, and if it's hidden. Why don't we want it to manage if it's a score also? We could add a member variable here for in the card. For the score. And when we initialize the card, we should assign it a score also. Or we could just do this and move this points array into that function and index it using the value. Why don't we want to do that? Well, the first option to put the member variable, that is kind of redundant because the score is based on the value of the card. So then we would be adding an integer when we don't really need one. And all the cards would get the score even though well, you don't need it for every card, you just need it for every value. So a little bit of waste of resources maybe. And also you need to make sure these are matched. So if you send in the score in the constructor, for example, you need to check that, well, okay, you shouldn't be able to assign the value 3 to the card with a value of 2. So that would add complexity to construction. You could probably maybe do it here inside instead, but then you could just move the array here and return the score when you ask for it. So why don't we want to do that then? Why did I opt to put it in the dealer? Well, you could think about it using the information expert again. Who should know the blackjack scores of a card? Should the card know it or should the dealer know it? Well, in reality, I guess the dealer actually is the one who knows it. The dealer knows the rules of the blackjack game, possibly the player also, and he knows how to calculate it. In reality, the cards, well, they are kind of like dumb. They have a color and they have a value and they can be hidden or not. But this card can be used in any card game. So if we add the scores into the card class, we kind of might make them specific for blackjack. And we can reuse it possibly for another card game, but then we need to remove this functionality probably. So in this case, that is the reason. And if you think about it, well, the cards, they don't know their score. It's the dealer who knows the score, or some kind of rules that knows the score. So this is blackjack specific. These are the score calculation for blackjack. It's not for some other game. And the dealer is quite specific already for, he's a blackjack dealer. So stuff like that is always something you can have in mind. So, all right. Next step is to actually use this and print it in some way. We now get into the controller, so we can get a hand and we can get the dealer's hand, but you should also send the dealer's score here. So the option we have now is to, okay, should we send it as an integer or should we send the dealer object into the view? In my opinion, it's safer to send it as an integer in this case. If we send the whole dealer into the view, well, there's nothing stopping the programmer of the dealer to start new game or do whatever he wants to do with the dealer. So I think in this case we should opt to do something like this. We got nothing. And that's because we haven't printed it. Ace of spades, you get 11. So that seems to be working. And we should do the same thing then for the player. Then we need to calculate the player score also. So in the controller, we need to send in oh, yay, 0.1. So, okay, we got actually this requirement fixed. If we look at the class diagram, it hasn't changed. Haven't added any dependencies. We haven't added any classes. So the design seems to be quite stable in this regard, at least, and that is good. Yeah, exactly. Something, if you paid attention, I did something here again. I copied this get score of hand into the player. Yeah, it's exactly the same as this one. So if we maybe scroll, let's do something like that, and do this a little bit bigger. Well, it's exactly the same code. Also, if you look at the class diagram, we can see that the player also has a hand, and the dealer has a hand. So, okay, what is going on here? And we can see that we have, if we fold that one, we have deal card and get hand. And in player, we also have deal card and get hand. So something is a little bit wonky here, so to speak. We have duplication in two different classes. And what should we do now? We can't have that in our code base. Any ideas? How to get rid of these functions that are actually duplicated? And also this attribute is the same in the dealer and player. Yeah, you could make a new model class with rules, possibly, but the rules can't have a hand. You could possibly get rid of this get score of hand stuff and put it in some kind of rule class instead. But I think, yeah, we have some kind of inheritance going on, and I also have this in the chat here. So some kind of inheritance, and what should inherit from what? Should we create something new, or should we use something old? Let's look at the class diagram again. So we can see that the dealer has the same thing as the player here. We also can see from the code it has the same functions to some degree, but it has some extra functions also, and it also manages the deck. And if we were to put a new class here, I don't know really what we should call it, and move the hand into this class, the player would become empty. everything from the player would be moved up to this class. So it is probably better to realize that the dealer he also plays the game. He is also a player in the game. He's a special kind of player, since he manages the deck. So if we just do this, and mess with the layout. If we let the dealer inherit from the player, we can get rid of this one. And realize that, well, the dealer is a special kind of player. And this is probably actually something we could have realized by knowing the domain a little bit better. Because it's somewhat apparent here already. We have the hand of the player and the hand of the dealer. So there is a good chance that we should be doing this actually in the domain model also. So we should go back. If we find something like this, we could go back so that the next time we are going to design and make a blackjack game and we have forgotten the design and the code is old and crusty, we could at least reuse the domain model. So we can realize that the dealer is a special kind of player, and maybe we could have done that from the onset, so to speak. Anyway, better late than never, and it can also be realized by looking at the code, so we can do a refactoring instead. So let's do this. Remove the hand. Remove the hand. Keep the start new game round. This function is actually in player now. Deal card is in player. And get hand is in player. So, not much left. And the player we don't need to touch. And things still work. So look out for this in the workshop. If you have duplicated stuff, if you have duplicated code within a class, try to make a function out of it. If you have duplicated the code between several classes, look for chances to either break this out or use inheritance. I think that this is about it for this requirement, at least. There are some wonkiness. You can probably play the game, just hit play and get a lot of cards in your hand. So this is probably something that we should fix in the rules. And so we need to check if we already are. We shouldn't be able to start a new game round if we already have. The game should kind of like be over. And I will just solve this by actually not creating the deck until we create a new game. And now we can't continue to play the game over and over. We must do hit or do stand or do quit. So this could be solved in different ways. You could add a state variable here. Bool is playing or something like that. I prefer to not add state if it's not really necessary. So if you can do these kind of things using your other member variables and find out if by using them instead, it's better, because otherwise you have a risk of this state variable not being in sync with the other variables, and the class kind of like behaves as if it is in a certain state, but other variables point to a different state, and you get a mismatch, and you can get all kinds of strange behavior out of this. And if you have more complex things like this, maybe you should put that in separate functions. But we won't delve into that really right now. So we added the inheritance, and we will be adding the rest of the requirements for hit and stand. And in my opinion, we don't really need to do sequence diagrams for this now, because we have made this start new game, and chances are that it will work kind of like in the same way. So if the player tells the dealer, I want a new card, who should handle that? Well, we need access to the deck, and we need access to the player, and we can look at our class diagram here, and see that, well, who has access to the deck? Well, the dealer. And who has the dependency to the player? Well, the dealer. And actually, also a point here is maybe we should add these dependencies to card here, and also to actually the player. Hello. And this is one of those instances where you need to use your judgment. Because this inheritance we have here, it's a really strong dependency. And you could argue that, well, the dealer inherits from player, and player already has an association to card. So the dealer is in some way already coupled to the card class. And in the same respect, well, the dealer is a player, so he's already coupled to this. So we don't need to show that he's really dependent on the player also. On the other hand, we have functions in the dealer that actually use another player object. We deal cards to another object, not just to ourselves. We handle another player object. So it can be a good idea to show this dependency also here. And also, the dealer juggles a lot of cards. It is not a matter of removing this dependency and the dealer will be free of a dependency to the card. If we were to remove this, we still have that the dealer takes something from the deck, shows cards. So he uses cards actually. So this dependency, I think, also should be shown in this diagram. So think a little bit about this. If you use inheritance, should you actually display so-called derived dependencies anyway? They add a little bit of visual complexity, but on the other hand, they tell, maybe in this case at least, a little bit more about the truth. If the card juggling was totally encapsulated in player, and the dealer really didn't do anything else with cards, I would not show it. So you need to think a little bit about these things also. Maybe one could do it like that, and we'll look a little bit prettier. But anyway, let's add the other functions. So we have in the view, we have the ability also to hit, and that is a good thing because that is probably something that we would like to do. to handle this in the controller. Could probably do a switch case here instead, probably look a lot nicer, so that I think is a refactoring we should do actually. Hit player. And we probably need to implement this also. And we will be a nice dealer, so if the player actually tries to get a card when he already has 21, we won't let him. So, but otherwise we will just get the card from the deck. And we will give it to the player. Should probably show it first also. Something like that. Play, hit, ooh, 17. Hit. This doesn't really seem to be working, does it? Knight, 3, 4, 10, 2, 2. 10, 13, 17. That's like 27. Let's try it again. Play 12, 5, and 7. That shouldn't be 12. Did we make a mistake? So the score should be 9, yeah. And then we have a hidden. This is for the dealer. It's not over 21, so return the score. And for the player, we have a value of ace. Interesting. So we should have 11. 5, 16, why are we here again? So, okay, that seems to be working. Play. Oh, we shouldn't be able to do that. 3 and king 13. Play, and we have 2 and 7. That's 9. Seven and knight 17. Knight and 14. Let's hit then. Knight 4. This is 12. That should not be possible. Yeah, probably. It should be like this, of course. I can't believe you didn't spot that. $17. Let's hit. Oh. Yeah, it could be right. 6. That is 7 and 5. 7 plus 5 is 12. The ace is reduced to 1. Bang. So anyway, that seems to be working now, and automatic testing I think would be a good thing in this particular function. But anyway, let's do the last one also. Let's do the stand. So we can get a working game here a little bit quickly. S for stand, I think. And what should we do in the stand method? Well, then the player has decided to, I don't want any more cards, so it's the dealer's turn to play. So what should he be doing then? Well, he should show all his cards to begin with. And then we have a little bit of rules to say that, okay, if the dealer has, I think, 16 or less, he should continue taking cards, and if he has 17 or higher, he should not take any more cards. So that is a rule that we will be implementing. And after that, the game will be over. And we will show that by just setting the deck to null at the end of this. So we should show all the cards in the hand, and this is something that the player actually has access to. The player has the hand, so we should probably move this function to the player. You don't need to write this, I think. Show hand. And while get score of hand less than or equal to 16, card, get card, deal card. And in the player we should add the show hand. Could this be it? Possibly. We will test run it after the break. But I think that maybe we have at least a chance to have a working game now. So, no questions? No? Alright, great. Then let's take 15 minutes of a break.